All right, so now we have our two files here in Artec Studio. You'll notice that they are not aligned. That's because they're not calibrated to any coordinate system. So we have our scan 1 and scan 2 here. We're going to go into our Autopilot section, which is right here. This is going to go ahead and guide us through the process. So the first thing you might have noticed is that the software did a quick base removal. So it removed the base of the first one, but looks like it didn't do it on the second one, and that's okay. So we're going to go ahead and edit that out. So in Autopilot, these are kind of the following the steps. One is going to be an editing tool. This will allow us to erase any areas or crop areas that we don't need. For instance, the table or this turntable. The software then is going to align the scans, and then we're going to create the model. So let's just go ahead and hit OK. So the first thing that comes up is a pop-up menu, and you're going to have a few of these guiding you through the process. This one is just letting us know which scans we're using. So we have them both shown here, which is by these little eyes. If they weren't showing, we could say select all. Here we're going to go to next. And this is going to let us go ahead and create the part. So scan quality. This is about geometry. So we have a couple options here. It's good or bad. Well, what's good, what's bad? You'll notice that there's a little question mark here, and that's going all the way down through this model creation, and it's going to guide us through what's good and what's bad. So bad geometry is flat geometry, fine geometry or repetitive geometry. Good geometry will have rich geometry. It'll have unique geometry, which you'll see in this part definitely has. So we're just going to go ahead and click good. Scan quality, texture, good or bad? Again, what is good and bad? So typically our bad textures are one color, low contrast, or repetitive patterns. Our good is multicolor, high contrast, or unique patterns. So even though this part is really just gray, it does have a lot of different grays in here. It has a couple, some rust spots because this is a part from the 70s. So I'm going to go ahead and say it's good. The next one here is hard to scan surfaces. So if you're familiar with 3D scanning, the top 4 images are going to be very familiar to what's hard to scan. So shiny objects, black objects, fuzzy objects, transparent. These are typically difficult to scan parts. Easier things to scan are going to be your matte, white, smooth, and solid objects. What's great about the Artec Space Spider, it does have a blue light technology which allows to scan some shinier objects and black objects. But for this purpose, you typically want to say if it's good or bad. So here, no problem. If it was a hard surface, you'd want to click this option right here. Object size. So this will allow us to give us a couple options on the size of the object. This one probably falls around that medium. So by default, it's already in that setting. The next one would be hole filling. So this part has some holes that we want. So we're not going to tell it to be watertight. We could tell the software let's not fill any, or we can say let's fill it by a certain radius. To know exactly some of these functionalities that are within the software and parameters, you might need to know what those holes, those radiuses are, right? So here we're just going to stick by default, but we can actually come and tell the software to fill it by a certain radius for like 1 millimeter or so on. Let's just stick with auto for this purpose. And then the next one will be model resolution. So what is model resolution? So this model resolution will allow us to either go by the default settings, which with the Artec Space Spider, it's going to be 0.03 millimeter. With the Artec EVA, we're actually at 0.1. So here we can actually adjust this to get better model resolution. As you'll note at the bottom, you can see here the software will give us some parameters to stay around. I'm just going to keep it to the auto so we're not messing around too much with it, but later you can actually come in and change those parameters. Polygon count. So typically this software will create a mesh for us to whatever size we want. We can tell the software that we want it just to be normal, or if I just know already I need this to be 534,875, I can actually do that. And it will optimize the file to be that, for that mesh simplification kind of thing. I'm just going to keep it at default. And then we have our texture here as well, so we can tell the software, let's go ahead and apply the texture. And model texture resolution. So texture resolution, we can pick here. The higher we go on the texture resolution, the better quality the data is going to be. But also the bigger the file is going to be. So let's go ahead and stick around in the middle. So from here, once we're done scanning, we'll go ahead and click next. Next thing that comes up is editing. So we do have some data that I want to definitely delete. So let's go ahead and hit next. I'm going to go ahead and hide that first scan, and I got that second scan here. So let's go ahead and delete that. Here, I'm just going to use my cutoff plane. I'm going to sample some of the data of the part. Anything that's highlighted in red is going to be what's going to delete. You'll notice that there's an area here which didn't get highlighted. So what I'm going to use my Control-Shift marker. I'm actually going to raise this plane up, and I'm going to say, let's erase it. Looks good. So I'm going to go ahead and hit next. And the software now is going to set me up to align. We can go ahead and align manually. Here I'm just going to go ahead and auto align. So my suggestion is if the part has a lot of geometry, the software can auto align very well. So if we had 2 or 10 different scans, we can let it auto align. The more scans you have, the probably nicer the auto align is going to be. But we can also go in here and do a pinpoint alignment. It's basically just clicking a couple different points over the part and then using those points for the alignment process. All right. So the software did auto align for us. I think everything looks good. If for some reason the software did not auto align it, we can go ahead and say let's align it manually. But auto align looks good, so let's go ahead and click yes. So here we go, the next process. So software is doing a fine registration. If I open up the workspace, what that's doing is it's looking at these individual scans, and it's actually doing a best fit. If you look here at scan 1, it had 403 frames. Scan 2 had 366 frames. So what it's doing there is doing a best fit between each of those scans. So scan 1, it's going to do a best fit. Scan 2, it's going to do a best fit. The next one here, number 2, is global registration. And now that's looking at both of those scans and doing a best fit from there. We got an outlier removal. So what outlier removal is going to do is if you see some of these little specks of data kind of sitting around, it's going to go ahead and remove those out for us. Now, all these parameters are already set kind of as a standard setting within Artec Studio. So it's not showing it here, but if we went into the manual process of doing it, you'll see all those parameters. And just a quick follow-up on here, when it does the global registration, you'll see this error of accuracy, 0.2, 0.1. That's a standard deviation. Basically, it's stating that at some point there are some things of data, maybe that are sitting out here, that are not aligning correct. If it's under 0.5 on the Space Spider, you're definitely pretty good. It's a good scan. If for some reason there was an error, you would actually see some exclamation marks, and we can go back and look at those frames and delete them. So you wouldn't necessarily need to go back and rescan. We just can delete those frames. All right, so now we're on number 4, which is fusion. So Artec calls creating a mesh a fusion. And what it's basically doing is taking the point cloud data that we've collected from the scan, connecting those points by triangles, and creating a mesh, or a fusion. So what I really like about this functionality of Autopilot is once I'm done with this, I can actually go on and do something else. So if I had another license of Artec Studio, I would have another computer. I could actually come in, plug that scanner in, and continue scanning. Set all this up, For the next, next part, click Autopilot, and then I can move back here to the file once it's done and export it out, and I can, basically be doing two things at one time. So I can get that scanning process done very quick. And while that's finishing up, I'll go ahead and talk about number 5, which is small objects filter. So small objects filter is kind of like the outlier removal. It just removes outlying data from the mesh, not from the scan data. And then you can see all that data is nice and clear. So here's our high accuracy mesh, Sharp Fusion. You can see all the nice clear data that we're capturing. We can even see the casting line here from the part. And some nice numbering here on the side. So now I just have the part on number 6, or the process on number 6, which is mesh simplification. So now we're actually optimizing this file to be a little bit lighter. We might not need it such a high file. So it dropped it probably about 75%, and you'll notice the detail's still there. And when it's doing that, it's making all the areas that there's maybe not high geometry, maybe like the flat areas, open triangles, and keeping any area with high geometry like these edges nice and tight. All right, and now the software just did number 6, which was texturing. Applying the texture, and there we go. Model is ready. So we just go ahead and click OK. And here's our 3D model. All done for us. So Autopilot is a really nice tool. My favorite part of it is that you can actually get something scanned and done while you're doing something else, and you don't have to come in and click and keep on clicking on the buttons. And you can kind of go on your way. So just wanted to kind of show you guys the final part as a mesh. I'll actually show you here as well. This is the wireframe mesh. So if I come in here, we can kind of come in and see the data. So a pretty good amount of triangles. When we talked about that simplification, we actually simplify those triangles on the bottom. You'll see here being a little bit more open, as if I came into the VW part here. Maybe the triangles are a little bit more tight. But texture all done. And this is a full 3D model using Autopilot.